Assalamu alaikum. I am Abdurrahim and the application which I have chosen for my demonstrative speech is Logicworks version 5. To tell you about it a little, Logicworks essentially is a digital simulator which allows you to work with circuit making on your desktop. In very simple words, it's the perfect app for you if you want to know about the functionality and if you want to know about how your circuit works or how any specific circuit works without having to make the actual 3D prototype. So having said that, having introduced the application, let's take a look about the diverse set of functions it has to offer and how this is actually used. So as you can see on the screen, I have with me different switches. These four are the switches. These are AND gates. These are the ICs which I have made for myself, and these are binary probes. There are different tools which are used in circuit making. If you're not aware of these tools, it's no big deal. There are thousands of these kind of tools available where my cursor is right now, and you can just select anything you want and just drag and drop. It's as simple as that. So I'll even demonstrate how this works. And if you want to filter out something and search for something specifically, you may also do that. So this kind of makes things very easy for you. So here I have selected two switches. I'll use an OR gate. Here it is. I just connect the wires like this, so you can very clearly see how easy it is to use this application. And it is one of the best features in my opinion about it. So yeah, right. So you can see this is the binary probe. This is where our result of this simple circuit of this simple gate comes. So if I change the switches, the result also changes. And to make things more clearer, more specific for me, I can even name the switches like simply like this, as well as the output and the gate as well, and gate. Apart from these, let's now take a look at the complexities. Right, this is one other example of a circuit which is a little more complex. So what I have done here is, this is the example of a 2 by 2 multiplier. What it does is basically it takes two double digit binary numbers and it multiplies them and shows the result right over here. In this circuit, what I have used is simply the switches. This is number one, A0, A1. This is number two, B0 and B1. I have used four AND gates, which are used to essentially multiply these numbers, along with two of the ICs, which I've made myself. How to make these ICs? These ICs are user-defined ICs, user-built ICs. They're not provided to you by the compiler. So, how to make these ICs will be coming up later in this video. So this looks like a complex circuit, but this is very simple. And I've shown you this example as to demonstrate how this application is used in a more real world sense. So now let's move on to the aspect wherein we see how do you make these ICs to suit your own needs. So now what we are going to do is make a user built IC so that our circuit can be more reusable. I'll let you know about what the function of ICs are. Let's link this concept to the code we write as computer scientists. You have functions which you can use to, sort of prevent your code from replicating itself. For example, if you want to take input thousands of time in your code, you don't write 2000 lines, you just make a function, and then you, for the 1000 times, you keep using that function. So similarly, our ICs, you just take your part of the code and you make it an IC. So whenever you need to use that circuit, which consists of maybe hundreds and thousands of different gates, you just use that IC instead of rewriting the whole circuitry again and again. So I'll show you a very simple example of how you may make an IC. So let's first of all filter from, these are the different categories as I've already mentioned, through which you can select your tools. I'll select one port in and one port out. Okay. Have I chosen the right ones? Connectors for CLF. Yes. Alright, I'll just flip this horizontally and I'll make a copy of this. Now I'm going to select two of the universal basic gates from the tools library. let me change this to all libraries and gate. And the other one, let's say we choose NOR gate. We just now connect the wires to complete the flow of our circuit like this, and we connect it to our output. Let's flip this horizontally as well. Now what essentially we need, what's left is basically to name these components so that when we create an IC, it's sort of it's clarified what's the input and what's the output. So naming is very simple. You just left click on whatever component you need to name. You click on the naming part and boom, there you go. O1 and O2. Now comes the functionality which sort of confuses most people. To make an IC, the process sort of is a little lengthy, but it's very simple. You click the file button, you select the new option. It sort of gives you all these options: VHDL, text document. What you need to do is you need to select the device symbol, click on OK. It sort of opens a new palette. Don't get confused, just simply follow the procedure which I am defining. You click on options, you select the the second option initially, and then you go to this option, create a sub circuit, and it asks you, as it says on the screen, to select an open circuit. You select whatever circuit you have made, which you need to convert, which you need to transform into an IC, and you click OK and done. So as you can see, here we have with us our inputs and the output pins. Now what you do is select the same option again, but now you choose the first part. Here it says the left pins and the right pins. So you, like this, you can separate your inputs and outputs. These are the outputs, these are the inputs, and right now and right here you may name you whatever you want to name your IC. I will write it as sample IC, and then you generate the IC simply. So if I need to work with this IC in the future, I'll just write sample IC and it's going to appear over here. After obviously I save this as sample IC in whatever library I need to save it. For example, if I save it in the connectors.clf library, it's going to appear right over here. So for example, if I go back to here, this circuit, these 1, 2, 3, 4, 5, 6 components can just be used on a simple click. So this is how this Logicworks version 5 makes things easy for you. Apart from this, now we'll take a look at some of the more complex circuitry. This, as you can see on the screen, is a circuit for adding two 4-digit binary numbers. This is A0, A1, A2, A3, and similarly B0, B1, B2, and B3. This is the circuit which I have built by my own. You can see right here I've chosen 4 of my own user-defined ICs, and this is the result which my circuitry gives me. And this is an adder circuit which I have simply selected from here, like this. So right now all my switches are on the 0 part, and 0 plus 0 is, as you can see, 0. A0 is the least significant digit in the first number, and A3 is the most significant digit in the second number, and same goes for the other numbers. So for example, if I make this 8 plus 8, it should give you 16, and as you can see, this is 1, 2, 4, 8, and 16. The results are aligned. So this sort of recognizes that what circuit I have made is the same as what the compiler gives me as in this device. So yeah, that's a functionality as well. This is how you can confirm that whatever device you're working on, whatever prototype you're working on, whether that's functioning in the right manner or not. Another example, as you can see on the screen, is the 3x3 multiplier. What this does is it's similar to the 2x2 multiplier, But the only difference, as you're able to see on the screen, is that it takes two triple-digit binary numbers. So right now, for example, I have in this text. Don't get confused about this text. It's very simple. You just click on this button right here. You select and you write whatever you have to write, like this. You know, it's very simple. So, anyways, right now what we have on the screen with us, the first number is 101, which is 5, and then 111, which is 7. So 5 multiplied by 7 should essentially give you 35. Now let's confirm that. This is 1, this is 2. So this makes 3, and this is 4, 8, 16, and 32. So 32 plus 2 plus 1 gives you 35. So as you can see, this is how I made the circuit and also confirmed whether or not my made circuit is correct. So yes, there's that. So we have talked about the specifics of this app. Let's now talk about the general features that it gives us. We have already discussed the text part, and unfortunately, no. So it's allowing us to do that. This is basically the main toolbar which we can use for our own good. In the view section, it gives us all these options. Like for example, if we don't need the status bar, we can just select it. We can just select it and it disappears. And if we don't need the time parts palette, which is this part, we just, it's as simple as that. So you can, customize your screen according to your own needs. These right here will just we will just consider the more important tools of this. This is zoom out and this is zoom in. This sort of fits your screen. This sort of fits the main box on your screen like this. And if you want to enlarge it, you can select. So you can select this option. So these are sort of your view palette, how you want your screen to be adjusted. Furthermore, this is the file option, which is pretty much the same in most of the apps that we use. If you want to open a circuit that you have made and that you've recently saved, you can just simply click on this and it appears right down here. And apart from that, we have with us the help bar, which is the best part about this app, because most applications, they don't give you this option. If you want to know more about Logicworks, you can click this option. If you want to look for other versions of Logicworks, you may go here. If you want to update your app, if you want technical support, all of that part is right here. So to sum up our video, Logicworks is a very diverse application which allows you to do something other applications usually don't. So in a way, it's sort of leading the market it is in. And I hope you found this tutorial helpful. If you have any other queries, you may ask me whenever you see me in university. So thank you for watching my video. And with this, I'll say Allah Hafiz. Thank you.